and classifying objects and images can now be done efficiently and at scale with the power of AI. Whether you're digitizing text from physical documents, looking to identify and handle unsafe or harmful user-generated content, or needing a solution to detect and classify objects in images at scale, we have a Jumpstart solution to help you learn how to create and deploy an image processing service, use a serverless architecture to enable on-demand scalable computation, and leverage pre-trained machine learning models for efficient image analysis. When building solutions using artificial intelligence and machine learning for image processing at scale, developers need to consider 3 things while architecting the solution. Storage. In this Jumpstart solution, we'll use cloud storage, enterprise-ready object storage from Google Cloud. Compute. In this case, we'll be using Cloud Functions, event-driven serverless functions. And of course, artificial intelligence. In this demo, we'll use the Cloud Vision API, which can be used to detect objects, read handwriting, and build valuable image metadata with pre-trained machine learning models through REST and RPC APIs. Instead of starting from scratch with your own architecture, Jumpstart solutions allow you to deploy and explore from the Google Cloud Console with packaged resources. If you'd like to make your own changes and customize it further, we've also built the foundation of the solutions in Terraform, which you can pull locally and modify as much as you'd like. And while these solutions aren't built to be production ready, they do include examples, patterns, and the Google Cloud tools we recommend you consider when designing your own architecture for your AI/ML image processing needs. Our solution consists of an example image processing service that analyzes input images and generates annotations for the images using pre-trained machine learning models. Let's do a quick overview of the architecture of the Google Cloud resources used in the solution. The image processing service can be invoked in 2 ways: by calling its REST API directly, or by uploading images to an input cloud storage bucket. When using the REST API, to start, a user sends an image in a request to the service's REST endpoint, which is deployed as a Cloud Function. The Cloud Function then calls the Cloud Vision API to analyze and annotate the image. The REST API returns annotations in the form of JSON to the user. When using the image processing service through cloud storage, to start, a user uploads images to an input cloud storage bucket. This upload event triggers a Cloud Function. The Cloud Function then calls the Cloud Vision API to analyze and annotate the image. And lastly, the Cloud Function stores the resulting prediction and annotation for the image in cloud storage. Once you hit deploy, the Jumpstart solution will guide you through these steps and give you a deployed solution to explore on your own. It'll automatically create and configure all the resources needed to run the solution. Once you've deployed this Jumpstart solution, you're free to click around and explore what services are being used in this Google Cloud project. Feel free to click through as an administrator and explore what tools and services are being used to create this demo, and check out all our resources and interactive tutorials to dive deeper into how the solution was built, linked in the description below this video. Want more information, resources, and troubleshooting tips? Check the solution guide. This is your best resource for any questions you have on this Jumpstart solution. Remember, this solution is for demonstration purposes only and is not intended to be used in a production environment. However, feel free to play around and customize it before creating your own custom architectures based on our provided framework in this Jumpstart tutorial. Ready to try it out yourself? Check out the links in our description to deploy this Jumpstart solution and see additional learning resources to dive deeper on this topic. We'll see you in the cloud.